Today's question comes from an industrial design engineer who's designing a holding fixture for one of his magnets. And the question that he had was, I've used some online pull force calculators and I'm wondering how accurate they are. Good question. Most online pull force calculators are very theoretical. So accuracy is not one of the things that you will find in those pull force calculators. As a matter of fact, most of them will be doing a pull force calculation on a 1 to 2 inch piece of steel. So if this is what you are pulling against, then yes, it could be accurate. However, we find that most of the pull force calculators are off by quite a large percentage. And the reason varies. It's not that the pull force calculators are bad online, it's just that they're using algorithms that may not fit your application. So it's important to know exactly what your application is and the parameters of your application in your magnet to get a true pull force calculation. So some factors that you want to look at as you use pull force calculations are, the first one is the contact with the surface perfect? Surfaces can be rough, which means that the two mating pieces, the magnet to the steel, may not actually be perfect and 100%. So there could be an issue where the magnet tilts or moves a little bit if the surface contact is not exact. Second is the coating thickness. A magnet coating can go anywhere from, on gold, a couple microns, all the way up to a very thick plastic coating. So in that case, you're looking at maybe a 0.5 millimeter to 1 millimeter of thickness, which pushes the magnet further away from the steel. So the further away you get from the steel, the pull force is going to be much less, or the holding force. The type and the thickness of the steel. Are you using a 1010 steel or are you using something else? And then the thickness of the steel. Is it a millimeter? Is it an inch? These things are all factors in pull force calculations. The size of the magnet. A very tiny magnet isn't going to hold near as well as a very large magnet, but it's hard to calculate a small magnet's pull force, and it's very hard to calculate a large magnet's pull force. So somewhere in between, we have to figure out what that size is, and then we can figure out the pull force. And finally, the perpendicularity of the pull. A pull force is calculated again with an algorithm that shows the magnet coming directly up from the steel. If your magnet is going to slide and has some shear force to it before it pulls, then it changes the whole number of pull force. Our suggestion when it comes to pull force calculators is use them as a guide to begin with. However, take the data and then do a reality check and do a real check on pull force. We can also do simulations and put in the actual thickness of the steel, the types of steel, the coatings that's going to be on the magnet. If there's a coating that's on the steel, then we can put those all in the simulation and get a truer pull force calculation, which may still be off by about 10%, but the reality is that may be much less than being off by one of these online pull force calculators. Thanks again for tuning in. Keep the questions coming at info@smmagnetics.com and log on to our website, www.smmagnetics.com. Thanks.